Okay, well, I'd like to start the fourth and final network engineering workshop session. My name is David West from GEANT. I have with me four distinguished speakers, all of whom I know and have worked with over several years now. Buseung Cho from Trieste, Jiangning Chen from CSTNET, Patch Lee from Star CC, who is here in place of Louis Choi, and finally Guy Roberts. They are the speakers. I will introduce them properly in just a moment. But first, let me just say that I, as work in my capacity of working with GEANT, I've been working in this region since I think it's 2003, which seems a vast length of time now. The region's clearly very important to us in Europe and to GEANT. It's an important regional community, and a lot of my work has been to build strong networks and communities between Europe and Asia. And in its early years, I led and managed the TAIN program, which these days is now handed on to and being further developed by Star CC. Today we have four presentations. The plan is that after those presentations, we will have a Q&A session with all four panelists. So if you would like to send in a question, you can use the Q&A from your laptop or from the Hover app to send us in questions, and I will do my best to distribute those questions, and we will answer those in the final stages of this session. So in terms of today, first speaker will be Buseung Cho. I should just say, for the speakers' benefit, that they will be given a reminder a few minutes before the end of their talks, so that they don't overrun too much. That will be just a little polite, gentle warning. But in terms of today, Buseung Cho, he's currently the director of the CoreaNet Center at Korea Institute of Science and Technology Information, which is, as you all know, is KISD. And he's been working at CoreaNet, one of Korea's national research networks, since 2005. And he's nowadays fully responsible for the CoreaNet project. He's also an assistant professor in the Department of Data and High Performance Computing Science at KISD campus of University of Science and Technology. He got his MS and PhD degrees in computer science in Korea, and his research interests include high performance networking, network management, future internet, SDN, and network function virtualization, which is quite a range, as well as being quite a long mouthful to say. In his spare time, he's also a member of the GNA-G Leadership Team and chair of the P4 application in SDN form in Korea. So over to you, Buseung, for your talk. Thank you.
Okay, David, thanks for the great introduction for me. Yes, I will share my slide. Okay.
Yeah, we see them. We see them fine.
Okay. Can you hear my voice clearly? Okay.
Yep, very clearly.
Yep. Yeah. Today I will talk about the current status of the GNA-G Strategy and GNA-G Working Groups activities on the behalf of the leadership team of GNA-G. Whole slide is already some of you were saw in the TNC 22, but I will update several slides and I added. And yeah, if you have any question during my talk, you can ask me. Okay, I will start. Yes, and my content is from the strategy of the GNA-G to the summary of our today's working groups. Maybe you know during the COVID-19, we cannot hold the in-person meeting. Yes, for example, the APAN and Internet 2 and NordNet, we failed. But we started to the online GNA-G virtual community meetings. And then from the 2021, and we run the 4 meetings in quarterly. And the GNA-G 22, we finally hold the in-person meeting in GNA-G 22. Yes, this is some pictures from during the GNA-G 22. More than 50 people joined our sessions and give us a great comment or some opinion for our directions of the GNA-G. Yes, during the meetings, several the comment from the audience, like what's the project, how to the project management for the GNA-G, or what's the missing the area, what's the missing topic in GNA-G, like the traffic, the management, or some kind of software-driven service. Yeah, this is a wonderful comment we can get it. Yes, now the leadership team member is just 5. David is the chair on our team. It's from the ANET, and Hobby from the CATEC, and myself, and Ivana from the PSNC, and Marco from the Red Club. If you have any question or any interest to the leadership team, you can send this mail links. Yes, during the TNC meetings, what's the end of the meetings? We wanted to take the moment to reflect our aims and whether we are achieving them. And we wanted also to decide as a communities what's the direction we'd like to take. And finally, also we too to provide when getting some opinion for some guidance or direction to the GNA-G leadership teams. Yes, everyone know about, maybe I guess already know about the GNA-G. This is a simple. GNA-G is the communities of all network professionals from all elements and organizations, and from all over the world. And just to main our speed is flux together a couple of the times of a year. And all work is done in the working groups, and all activity also is overseen by our leadership team. Our optimal goal is to work together to better align our resources, like the human resources, also the infrastructures, and to make the continent to continent, the interconnection to be more efficiently, and for global science collaborations and transnational educations. And if you can check this kind of whole message in our GNA-G website, you can check it. And this is our vision. The most important thing is we are so diverse. It means every country and every continent has their own goal to do something in our element community. So speed is also different, and accessibilities and capacity, all things different. But I like that the GNA-G and GNA and GLIP is the previous our bodies is like that. GNA-G also wanted to continue to the work of making the interconnection of these whole networks more efficient for the science and education, and also providing the model for the more effective use of our whole resources in building this kind of the networks. By working together, the elements over the world can provide a better service, and also we can make some kind of the agreement for like the blueprint, which is that enable the RNA networks to align the whole this kind of the interconnection network and bandwidth. Yes, this is a mission. Our primary mission is to support the global research and education to using great technologies and huge kind of the huge infrastructures and investment of the all participants. Yes, we have to bring together the researchers and analysts and the GXP and operators and the regional and other R&D providers in developing the common global infrastructures for support of these kind of needs. Yes, this mission is data movement is essential for to do that from the in terms of the element communities. Also, to do that, to have we have some working group to fulfill this kind of the mission, and develop the network architectures and service architecture for highly advanced intelligence networks. And yes, sometimes we can getting together to enable our new networks and for the funding or the procurement of the capacity for the global interconnection. And also the good thing is we can make some kind of the best practice to move the data to end-to-end some kind of experience. That is very important to share this kind of knowledge to the all end members. And yes, we also wanted to promote the general understanding of the reach and connectedness of the global LLM communities. This is the whole body of the GNA-G. Is the underlayers. We have some kind of the the infrastructures like the GEANT, global research and education networks. That is made by some kind of collaboration in between the continent, like the already AER and APAN and ANA and AIM-like. This kind of a great intercontinental bandwidth or networks there. GNA-G don't have this kind of physical networks infrastructures, but this kind of a consortium make their own choose the global network. This is based on we think that the GNA-G spirit or the mission. And under the layers, GNA-G architectures and service are there. And nowadays is yellow one is this is individual the working groups or there under the architectures and data intensive science and GRAM mappings and organ science and telemetry. That is all kind of the research and development levels. And for this, we also have the operation level working groups like connecting the offshore student and securing the GRAM and the routing anomalies and the network automation. Some working groups already they had some kind of session already in this kind of APAN. All activities overseen by our GNA-G leadership team. Also, we are working together with other parties. Yes, this is a GRAM. Great I didn't know the AER and the ANA and APAN and AIM-like. This kind of great infrastructure scale. Yes, finally, I'd like to explain the summary with today's working group activities. Network automations and the audible science and the data intensive science, collecting options as students. This kind of the working group is so active in this moment. So I will summarize their activities. Yes, the first one is network automation, led by Ori Mitchell from ANET and Miguel from the third. They developed the catalog of the common network automation tool for use. All thing is within the element to drive the automated configuration. 5 minutes left. 5 minutes. Okay, just 5 minutes left. Security auditing and change control. Yes, some activity is active, but is the important thing is what's the direction of this kind of the network automation. And from this year and the next year, they are focusing on the identify the common set over the network automation. This is very important because ClearNet, we are also starting to the network automation or how to manage the network infrastructures, how to automatically provide our service to our users. But already Internet 2 or the Surf and Jiang also make these kind of things. So we believe that make some kind of common set of network automation. That is very important role. And other sense, this is led by the CSTNET, is Tom Leoma, and the other Marcus from the RMP and Hans from the SERP. You already may know about the Audible infrastructures to provisioning some kind of circuit among the interdomain. We can use this kind of tool to automatically provisioning some dedicated circuit to the over the world. In this moment, there are handling so many items like the data flow verifications and troubleshooting the services to the facility user research and development. They're very active. And next one is a data intensive science working group that is led by Harvey. They also have so many items there to list, already listed up in this slide. Maybe, but they are also covered so many network technology, but also the applications or science applications. What's the requirement of the application, and to meet this kind of requirement, what's the new system, new kind of technology should be adapted to meet this kind of the requirement. So like the people technologies, already some progress are already presented in these workshops, and 400 transmission technologies and segment routings was there. So they also wanted to handle and approach to the new technology like the NDN or the modern system for the oil service. This whole thing is already active, and if you want or join or interested in this kind of the whole working group, you can join in the working group. Finally, this is a special working group. It's connected offshore student, led by the chair is David. During the COVID-19, to connect some service in commercially, we can also using some VPN service to access some cloud. How to make this kind of thing is happen. So first one there is for the foreign student, they want to access in China in university. They need some kind of a VPN service that is provided by Alibaba. Yes, to do that, NordNet and other countries was working together and provided this kind of connecting service to all the online users. And also activate routing working groups is led by the Brenna. They are finding out some asymmetry the passes or the misunderstood passes were there. They're finding out the way to how to correct the passes. This kind of thing was happening in this working group. GNA is they also wanted to make some kind of new
1 minute left
global research network map. So if you're interested in the working together with this working group, you can join it. And you wanted to add your link or the network to this kind of map, you can also can participate to this working group. Yes, our future things. We will keep the virtual conference in quarterly, but we also wanted to make the in-person meeting in the near future. Still not fixed. So if there some kind of the schedule or a meeting schedule was fixed, we will announce it. Okay, close it. Just the most important thing is participate. Everyone can participate, and you can check all kind of the message or the information on this website. And if you want interesting or want to something to using the whole community, you can also mail to this mailing list. Thank you.
Thank you very much indeed, Buseung. Yep. That's a very interesting presentation.
Yep.
I particularly like the fact that GNA-G is such a collaborative group, And I also like particularly the fact that it is clearly tackling very practical issues and problems, and having a fair measure of success as well. So I think it's a very useful body. I'm very glad that you've managed to continue to meet virtually. I mean, it's good. I mean, I always think it's good that we should be using the technology as much as possible. I mean, we promote it, we develop it and promote it to others. We should definitely do that ourselves as much as possible. But it is also very nice when you do manage to have face-to-face meetings and things get done there that can't always be done with virtual meetings. But anyway, thank you very much indeed for your talk. We will have questions in a panel at the end. I notice I don't see any questions as yet. If anyone in the audience would like to ask a question of Buseung or someone else, please put it into the Q&A slot on the Hover window or on the app, and we'll use that later for the presentation. Thank you. So, second speaker is going to be Jiangning Chen from CSTNET. Ms. Chen's responsible for the national and international resource cooperation and development for CSTNET. She's taken charge of a project responsible for establishing international transmission platform for ITER, the huge fusion project that many of us are also involved in. She's also joined and partly responsible for the design and coordination of setting up CST exchange points in Pacific Wave, Starlight, and SOE, Singaporean Open Exchange. And I'm very much looking forward to hearing her update. Jiangning, over to you.
Okay. Thank you, David. And I'm Jiangning Chen from CSTNET. And it's really my pleasure for having the opportunity to give an introduction on CSTNET update. And first, some brief introduction on the current CSTNET domestic results. For CSTNET, we covered more than 30 provinces around China, and we have totally 12 regional branch centers around China, like Shanghai branch, Guangzhou branch, Chengdu branch, and we have connected more than 300 institutions around China, and more than 100 institutions coming from Chinese Academy of Sciences, and others coming from some national level academy organizations. And most of the regional branch centers have 2.5G to 10G to Beijing backbone, and our end user has reached up to 1 million. And also, I want to mention that this year we had successfully applied a new project from our government to support us to have a whole network upgrade, which will be a whole ring network, and it will be built up based on light path, which I will give an introduction later. And next slide, some current connections in CSTNET. First, some domestic results. About the commercial domestic results in CSTNET, we have 30G with some major ISP in China, like China Mobile, China Unicom, and China Telecom. And about the science and research and education results, we have 60G with CSTNET in China. And also we have 40G connections with Beijing NAP, Shanghai NAP, and Guangzhou NAP. The 3 NAPs were built by Chinese government, which support all the ISP have the direct connections in China. And next, some information about the international results. We have 3 exchange points. One is in Hong Kong at Mega Eye, and in Mega Eye we have Strategy, that's commercial international export. We have strategy connections with PCW and Cogent. And about the research and education results, we have several 10G connections with Asian Pacific partners like NICT from Japan, KIST from Korea, and HARNET in Hong Kong. And also we have two other exchange points in the US. One is at Pacific Wave in Seattle, and the other is at Starlight in Chicago. And also we have 10G connection. That's a cooperation between GEANT and us. And that's circuits between, and that circuit is between Beijing to Frankfurt. And next, I would like to introduce some feature about CSTNET. For us, our objective is to provide the data-intensive and big data-driven science application services. And our users include more than 80% of Chinese major research infrastructures and more than half national scientific data centers and supercomputing centers, and also several hundreds of field stations have the connections around China, have the connection to CSTNET. And also we support some major international cooperation projects like ITER and SKA. And this slide shows some typical application we have supported. We not only have the connection with more than 80% of our national research infrastructures, but also we have support many international collaboration plans and our national scientific pilot plans. And this is the example on the pilot program we had supported. In the program, that's the example we support for the space research. And in the program, we not only built a scientific VPN transmission for all the projects in the program, but also we provide the offsite data disaster recovery service, measurement service, and data processing services for all the projects joined in the pilot program. And next is example on supporting for the typical major research infrastructure. That's the FAST. FAST is the world's largest single caliber and is the most sensitive radio telescope in the world. And it helped us to identify the newly discovered pulsars. And another example is the application we supported for high energy physics. We have supported many famous experiments like the neutrino experiment in Daya Bay and the Juno experiment that location is in Jiangning. And also we support some famous cosmic ray experiments. One is Yangbajing, which is located in Tibetan Highland, and also the LASSO, that's another cosmic observatory, and the experiment is located in Sichuan province. And also for the high energy physics support, we support some international cooperation like LHC. And next, we some example about we support for the big science, international big science application program. That's the example of ITER. ITER program is one of the largest and most influential international research cooperation projects in the world, and is help the human being to solve the future energy problems. And for CSTNET, we have undertaken the major project from the China Ministry of Science and Technology. And we had set up the network platform and application platform for ITER project. And another example on supporting the big science program is the ISKA. ISKA is the Square Kilometer Array Radio Telescope, which is the second largest international science project in China after the ITER project. And this year, CSTNET has signed the MOU with Shanghai Observatory to support their future collaboration with Europe, Australia, and South Africa on ISKA project. And next, I would like to give some introduction and update introduction on our international cooperation. The picture at the bottom is the current traffic between China and Europe. And we have cooperated with GEANT for more than 10 years. And the current circuit is 10G connection. For we have supported many important big science applications. We can see that the current traffic of the 10G has been very, very full. So in May of this year, we have signed the 100G upgrade MOU with GEANT. And currently, we are doing some preparations for the tendering for the two new 100G to support the cooperation. The 100G circuit is from Beijing backbone to Hong Kong, and the other new circuits, 100G circuit is from Hong Kong to Singapore. And also, by the end of this year, we will set up the new exchange points in Singapore at Singaring Open Exchange. In SOE, that's also a new 100G connection. And we would like to set up the new connections with all the research and education networks who is dropped in Singaring Open Exchange.
5 minutes left. 5 minutes.
Okay, thank you. And next comes to the last slides of my presentation. Like I just mentioned in the beginning of my presentation, I have mentioned that this year CSTNET has successfully applied a new project from Chinese government to do the whole network upgrade. And the picture on the left is our current network status. We can see the current network structure is a star network. All the branch have their direct connection to Beijing backbone. And on the right is the new network we plan to construct. And the construction will begin by the end of this year. And yeah. The construction will begin by the end of this year, and it will build up based on light paths, and each channel will support 100G to 200G, and the whole network is a full ring network, which will provide a better redundancy for all the research elements all around China. And also it will cover the nearly most of the provinces in China. And about the backbone will be extended from Beijing to Guangzhou, Shanghai, and Chengdu. And that will provide a better balance for the data transmission. And also in the next step plan, we will set up the new exchange points in Singapore, and we will upgrade our international research and education resources connection from the several 10G to 100G level. And all the next step plan, the objective of our next step plan is that we want to promote all the elements like such as the major research infrastructure and more than half of the scientific data center and the supercomputing center and the hundreds of field stations and the major international cooperation program to have a better international research cooperation with the world. And that's all of my presentation. Thank you.
Thank you very much indeed, Jianjing. Again, a very interesting presentation. It shows what a lot of has already been achieved and the exciting plans that you have in China. I should just add perhaps that yes, as Jianjing you have said, GEANT and CSTNET signed an MOU in May this year for upgrading capacity. In your slide, Jianjing, you've shown the CSTNET part of that plan, bringing 100G to Singapore. The other part of the plan is GEANT's part of the plan, and under our part of the plan, we will bring an additional 100G capacity from Europe to Singapore, and then we interconnect there at the two at SOE, and we're very much looking forward to that. It's very much needed as our capacity is extremely well used. Some would say it's full. But it certainly needs upgrading, and as Jianjing has shown on her slides, it's major scientific projects which are really driving the development and expansion of network traffic. ITER and SKA being two of the big ones that are going to require more and more capacity over this coming decade. So, yeah, I mean it's a one-way street, this, I think, for more and more and bigger upgrades of capacity. So and getting to 100G is obviously an important step in that. So thank you. I apologies to everyone in the session that I managed to send a chat to the whole meeting that was intended for one person, but it wasn't a bad one to do, because what I was encouraging was encouraging someone to send in his question. Please feel free and uninhibited for sending in your own questions about what you're hearing, either from so far Jianjing and Buseung, but then also from other speakers, and we will come back to those questions in the panel session. I've noted the one that's already come in from Patch Lee. So good, thank you very much indeed, Jianjing. Next speaker is indeed Patch Lee from Tainstar CC. Patch is head of the project management team at Tainstar CC. His main responsibilities are for procurement and managing of the Tain network, which has grown substantially. Secondly, for deployment and promotion of services, applications, and capacity development for the economically developing countries. NREN's through a platform of calls for proposals, which many people here will have been involved in. Been a major program. Before he joined Tainstar CC, he worked for Korea Telecom, KT, in South Korea for over 10 years in dealing with global data business and procurement, as well as network engineering. So I'm very pleased to welcome Patch, and I'm looking forward to your talk, Patch.
Okay, thank you very much for the kind introduction, David. I thought I was at the last. Guy Roberts were ahead of me. That's okay, right?
You've been promoted.
Wow. Oh, thank you very much. Well, I'm very honored, actually. Yeah. Hello, everyone. Nice to meet you again. And it is my great honor to be here with you. My name is Patch Lee and works for TAINCC, which manages Asia Connect project. I'm here to present to you with the title of current status and prospects of TAIN network. As you can see, here are several topics I prepared for you. First, it's about status quo of TAIN network. And then I will provide you with some information on its growth and change during the past 5 years in terms of traffic volume and bandwidth. Lastly, I will shortly inform you of my personal idea to how to secure TAIN's sustainability in the coming years. Okay, here is the topology of TAIN network as of October 2016. Really, time flies. At that time, TAIN's backbone was mainly made of 10 gigabps, as you can see, and access links. Those are they varied from 10 Mbps to 10 Gbps. Here is another topology of a TAIN network as of July this year. We have 200 Gbps as a backbones. One is for the route between Asia and Europe, procured in 2019 by 6 parties, including TAIN-CC. And the other one is 100 Gbps between Singapore and Hong Kong, which is contributed by Japan, Hong Kong, and Singapore. We keep 10 Gbps between Hong Kong and Beijing as we did before, with the half of the capacity is donated by China. For access links, their capacities currently vary from 10 Mbps to 100 Gbps. Okay. Oops, sorry. This slide illustrates what the changes are for the last 5 years. Firstly, we welcome the 3 countries to be connected to TAIN, namely Bhutan, Myanmar, and Mongolia. In terms of bandwidth, as I mentioned earlier, we noticed many of links over 100 Gbps for backbone as well as access links, as you can see. This and next slide actually illustrates a different angle for the change of bandwidth. We saw 8 times increase of bandwidth in total of the past 5 years. I guess one of the main reasons of this growth can be attributed to the competitive telecommunication market. I mean, we saw a significant plummet of price of capacity thanks to the prolonged usage of existing fiber optic cable, submarine cables arising from technological evolution and continued launch of new cables into the market. We used to classify countries of TAIN project in 2 groups, beneficiary versus non-beneficiary. The former is mostly composed of economically developing countries, while the latter is of developed ones. In view of this classification, as you can see in this slide, the group of non-beneficiaries has shown a much better performance in terms of bandwidth growth. I presume the plunging of price, namely price erosion, favored and provided a better opportunity for the affluent and rents for them to afford the higher bandwidth, such as 100 gig BPS, one that they couldn't dream of before. I regard the trend of price erosion transpired dramatically, especially in the developed countries region caused by telecommunication markets fierce competition from supply versus demand. This trend looks like to be continued, as I presume. Relative poverty is deepening in the society throughout the world. The consequence would be high possibility of widening gap of capacity availability between developing and developed countries, which really saddens me, apart from what we can do to address and tackle this issue. Okay, from now on, let's briefly look at the growth and change of traffic volume and the users in TEN network. Okay, if we compare traffic volume 2021 versus 2016, we saw about 83% increase over it. From 2019 to 2021, the years were bound up by COVID-19 pandemic. We saw ups and downs, dips and bouncing backs. I regard no consistency or meaningful trend I can find there was. As you might be aware, since TEN does not accommodate any commodity traffic, we could not take any advantage of having commercial internet links as other NRANs did during the period of pandemic. Okay. If we narrow down traffic volume to the last 2 years, we saw a 57% increase of traffic volume in 2022 compared with the figures of 2021, which is quite encouraging. Based on the figures, I presume we can recognize that TEN is almost out of impact from COVID-19 pandemic. Here you can see changing from another different aspect. I mean, in terms of users, the information is captured from the link between Asia and Europe, and it shows who are using most of the link in view of top 10 list for the year of 2021 and 2017. As you may notice, the scene has not much changed much. I regard based on the identities of from BGP-AS numbers, applications such as high energy and climate weather data are still dominant forces, and we saw South Korea and Hong Kong and China moved forward in the list. Lastly, let's see a way to secure sustainability of TEN network. From this slide, I must have your kind understanding. This is my personal opinion, not that of my organization or project. Actually, at this point, our organization's focus is much on how to close smoothly current phase of Asia Connect. So clear path to secure sustainability of the network will be decided at a later date. Anyway, if you ask me in person what the best way is to achieve the sustainability of network, I believe it's in IRU. I believe that it should be our overarching strategy for the future of the TEN network. However, unfortunately, even though I came up with this IRU thing for the last several years, I had not developed much progress, and I feel a little sort of ashamed for that.
5 minutes left.
Great, thank you a lot. Thanks a lot. As you are, I can make it, yeah. IRU stands for indefeasible right of use. Believe it or not, IRU is seen that you could recover your investment in 3 to 5 years while enjoying 10 to 15 years of connectivity. Here is the first and only exemplary case of IRU, Asia Connect procured in 2019. As noted, 10cc collaborated with other 5 parties, including ANES, Singapore, and Jiangning, to procure 100 gig BPS between Singapore and London. I'm not sure who was the initiator of this collaboration. Was it Mary Fleming who left ANES, or Francis Lee, or you, David West? Not sure. However, one sure thing is this collaborative approach was really good methodology to employ in order to minimize, of course, costs, along with less undermining of capacity availability of for each participant. So I would like to take my hats to the initiator of this collaboration as well as all the other participants. Okay. Here are several candidates for IRU procurement. I regret personally we did not join our forces with Hong Kong, Japan, and Singapore to procure 100 BPS for the route between Hong Kong and Singapore. Anyway, the information here is quite out of date, so I need to revisit it and to update relevant costs. By the way, before I start, I checked, I read the names of participants and couldn't find Basuki. Actually, Basuki, the other day, on Monday, in the governance meeting of Asia Connect, he proposed IRU between Singapore and his country, Indonesia, as a way to minimize connectivity cost. Hearing his comment, actually, I welcomed it more than anyone else. So I really look forward to having a fruitful result in the coming days in this regard. Okay, that's all I have. Thank you very much. Thanks a lot, David.
Thank you, Patch. Thank you very much indeed for that. As to who thought of CAE1, well, I think that was very much a team effort by the European and the Asian parties working together and wanting to collaborate, I think. And so I don't think there was a single owner of that good idea, but it was mutually supported, I think, which was an important thing. I also thought your slide showing the relative amounts of bandwidth from developed versus non-beneficiary, beneficiary but non-beneficiary countries over the last 5 years is a very well, not is in some ways quite an alarming statistic. It's yes, inequalities in many areas of the world have increased rather than decreased in recent years. Despite much good work as well to sort of provide support for the developing countries, as has clearly been done very successfully in many projects, including Asia Connect. But yes, I think that shows one of the things that should be focused on in the coming years. And I would agree with you that the IRU opportunity is one that would help sustain R&D working in the Asia Pacific region much more. Perhaps we come back to that in the Q&A. later. Thank you very much indeed for that. Again, let me ask anyone who wishes to ask questions, please put them in the chat window of the Hover app, or in the chat of this conference itself, if you wish, as Pat did earlier. Wherever they are, we'll pick them up and use them. So on to our fourth and not least speaker, Guy Roberts, from my own organisation, GEANT. He joined us in 2006 as senior network architect. He's responsible for the introduction of new transmission technologies into the GEANT network, and currently working on the design of the new GEANT network, which is underway. He's technical lead for a new spectrum service in the GEANT network, and is working on quantum key distribution, optical time frequency network, leading field trials of QKD and time frequency distribution in the GEANT network. He received a PhD in photonics from the University of Cambridge in 2006 in the area of DWDM subsystem design based on integrated photonic components. So he's clearly got a lot of experience, and we've been using it to its full in the last few years in GEANT. So over to you, Guy, for your talk about the
thanks, David, for that kind introduction. Before I jump into my presentation, it was a very interesting discussion on IRUs from Patch, and I think my talk will try and elaborate a little bit on how we've deployed and made use of IRUs in the GEANT network. So I'll just share my screen. Can you see my screen?
Yep. Yeah, we see and hear you clearly.
Okay. So I'm going to cover a range of topics. Start off with the usual update on where we are with our network build, and then I'll go into spectrum services and what they are and why they're really important to us. And this ties very closely into the discussion on IRUs. So that's a neat follow-on from the previous discussion. I'll talk about some of the technical trials we're doing on the spectrum service, and I promised in my introduction, or my summary of this presentation, to talk about some of the upcoming optical technologies that I'm working on. So I'll touch on those. So I guess for those of you who've been following previous APAN meetings, once every 6 months, I've been giving an update on how our network build has been going. So here's the latest update. So in the map, you can see, based on the colors, how the build is going. And the good news is the green areas are now built and delivered. So those green lines are now operational. The orange lines are now acquired. That is, we've acquired the capacity, which is going. I'll talk about what that is. That's going to be fiber or spectrum IRUs. So they're acquired and being put in place. And then the darker blue lines is where we've agreed the way forward, and we're in the process of tendering for capacity there. And then the lighter blue lines, particularly the least capacity Israel and Cyprus, are still in planning phase. But we're making good progress, and we expect to have the network built early next year. So in terms of what we want to try and achieve out of this new network, obviously the reach and capacity is much larger than the previous network. But what we really want to identify is sort of in that sort of yellow, highlighted yellow area, we have very rigorous competition within Europe. As a free market, a lot of players, strong price competition. So we can purchase capacity in that area at a very good price. But in other regions, we don't necessarily have the same level of competition, and it's really quite a variable thing across Europe. I won't bore you with the details, but just say it's quite variable in different markets. But we have a obligation to deliver a equal level of access right across Europe. So we want every European country to have equal, similar costs based on a cost share model, which is we try and be equitable, but we have a challenge around what the cost of procuring capacity is. Different levels of capacity requirements in different regions. As Patch was saying, IRUs are really the core of the way we're building our network. If we get an IRU on fiber, that gives us a lot of capacity, potentially up to 20 terabits of capacity with a fully occupied fiber in the C-band. And that's a lot of capacity, and an IRU there is a big commitment. In the past, what we've tended to do is go for leased circuits, which means that the capacity is fixed. And if you go for an IRU on a leased circuit, that's great, but over a 10-year period, you can't grow the capacity as the technology grows. With the fiber IRU, it's great. 15 years of fiber. As the transponders get better, you can increase the amount of capacity on that fiber. So what we're looking for was a solution to fill our requirements between 20 terabits and 100 gigabits. And so we've pushed the market pretty strongly. Sebastiano Buscaglione has really worked very strongly with our NIAC and with the network providers in Europe to push for the provision of spectrum services. That's where the network provider gives us a spectral slice on the C-band. It might be 200 gigahertz, it might be 500 gigahertz or more. But basically we have this line of options. One end, 100 gigabits per second lease capacity, the other extreme up to 20 terabits fiber. And then we've got these different versions of spectrum, which I'll talk about. So why is spectrum good? Well, as I've just explained, it's great for us. We can get long-term certainty with an upfront investment. But it's also good for our customers, even though they have smaller amounts of requirement in capacity. And there are technology changes which are going on. For any of you at TNC, we did a workshop there on what's happening in optical pluggables. If you missed that, I believe the slides are online, and I would encourage you to take a look at that. But there's strong changes in the areas of ZR and XR pluggables, which is really pushing down the cost of 100 gig and now 400 gigabit optics. And those pluggables can go directly into your router, and means that if you buy Spectrum, you can light that directly from your router, and you don't need any DWDM equipment, and your transponder costs just drop down to the cost of a pluggable. So this is a great cost improvement for our customers. So we really believe in this, and we've set up a group within GEANT to work out how we can deliver those services to our customers. So that's the Spectrum Connection Service team, which I'm leading. But we, as I say, is that the tagline there is Spectrum is here to stay. It's something the big content providers believe in, and they're really pressuring the vendors as well, to network operators to deliver that. So this is my team here. It's the known as the Work Package 7 Task 2, or the Spectrum Connection Service team. We've written a document which is a EC deliverable, D7.3, product description of the GEANT Spectrum, and it goes into quite a lot of detail about the challenges and how to meet the challenges of building spectrum as a service. And it applies not just to GEANT, but for all the NREN partners when building their spectrum in their networks. And you can see there the partners involved in that. So what does it included in this document? We've kind of defined a reference model which defines a multi-domain environment, because the GEANT network is very multi-domain. We have a core, which is or a backbone, if you like, which is the GEANT network, and each country has their own national network. So to make this service work between cities in destinations, institutions within Europe, we need to build it as a multi-domain service eventually. So we're starting off initially with a single domain service within GEANT. We aim to develop a multi-domain service. So we define the processes and information that needs to be exchanged at the network-to-network interface and the user-to-network interfaces. And then to develop that further, what we've done is we've run a series of field trials within Europe. That started off back in 2020, and the first field trial was from London to Amsterdam. And in that one, which I'll talk about in a moment in more detail, we've provided a single domain service between two endpoints, London and Amsterdam, where we provide spectrum to our customer. In that case, it's SURF. The second field trial, which started in 2021, was Copenhagen to Helsinki. This is interestingly is the other way around. What we've actually done is we're buying spectrum. So the spectrum service here was built by the Swedish and Finnish network providers, and they provided a two-domain, multi-domain, or two network hop of spectrum, which they're selling to GEANT. We're buying from them, and that's based on an IRU as well. And then thirdly, this year we're initiating a pilot for Geneva to Bologna multi-domain trial, which was interesting collaboration between GEANT and GAR. So how do we build spectrum in the GEANT network? Well, what we use is a DWDM layer is built using a product from Infinera called the Flex ILS. It's a compact form factor DWDM system. At the core of it, it has a flex grid wavelength selective switch, which gives us a sort of granular slicing of spectrum, slices of 6.25 gigahertz. Supports extended C-band, and then on the right there you can see that within GEANT we sort of bookend the service with a Flex ILS box, and we then provide to the customer a slice of spectrum, anything from 100 gigahertz, 200 gigahertz, and higher. And then so that's the provider in blue, and then in the case of where we are buying spectrum, as shown in this diagram, we would also terminate the spectrum in GEANT with our own Flex ILS, which allows us to aggregate the capacity that we want and forward it onto that spectrum service. So a bit more detail about the trials that we're running. So the first one, which we've done and is now effectively moved from a trial to a pilot, has been running for over a year, is a spectrum capacity between Amsterdam and London. which we're providing to SURF. Yeah, that is SURF, use their own transponders at each end. So we provide the transparent optical channels. In this case, it's 2 channels for them to light up, and that's been operating, as I say, actually for pretty much a year now, and we're happy with the performance of that, and we will turn that into a service probably early 2023. So the multi-domain service that we've trialed is between Helsinki and Copenhagen. So it runs from Copenhagen to Stockholm, and that section is built using ADVA technology in the CSTNET network, that's the Swedish network. And then from Stockholm to Espoo, which is basically next to Helsinki, is on fiber, and the transmission system operated by the FUNET, which is the Finnish network. So they've kind of bookended two sections of spectrum. We're actually buying from them a very large amount of spectrum. We're buying, we have an IRU on 1,200 gigahertz of spectrum. So that's in 2 bands, one at sort of the blue end and one at the red end of the C band. And that will really future-proof us. We've got, I believe it's 15-year IRU on that. And we will add wavelengths as needed. So we had a very good trial on that, and we were able to run 200 gigabit 16 QAM with 69 gigabaud in a 100 gigahertz channel, and it runs free at error-free with a signal-to-noise ratio of around 20 dB. So that was a good result, and that is now moving from trial to production phase over the next few months. So that's the spectrum service, and what I want to now kind of touch on in the next few minutes, I think I've got another 5-10 minutes, is some of the other initiatives that we're carrying out in GEANT. So as David mentioned, I'm been involved in the design of the new GEANT network, but we're also looking at new technologies that we can build on the optical infrastructure. So we kind of refer to these as non-data technologies, and there's 2 that we're investigating at the moment. One is quantum key distribution, and the other one is time and frequency distribution. I'll start with the Euro QCI. I don't want, well, there's been 2 initiatives here. One of them is some lab testing that we've been carrying out ourselves, which I won't really touch on. But what I do want to mention, I think, is of interest from Asia, is the amount of funding that Europe is directing towards quantum, and in particular key distribution within Europe. So the European Commission has identified the need for a European-wide key distribution infrastructure, and this is known as the Euro QCI, and it's funded on a national level. So each nation has its own separate funding for this. That's due to security concerns and the idea that each country should have its own independent key distribution network with nationally, and later on they will be linked internationally as well. So we're currently in the phase where all 27 EU member states have participated in this, and that participation is being evaluated at the moment. What I would like to highlight here, and I think is of interest to this community, is that 11 NRENs partners within consortiums that are have put in bids for to build the quantum key infrastructure within their countries. And in fact, informally, I think the results of that have been communicated internally, and I think I believe it hasn't been publicly announced yet, but that will be publicly announced shortly. And I think there's been a high success rate among those countries identified within that map. We're also doing within GEANT some evaluations, some early evaluations and field trials on quantum, but I think that's beyond the scope of the talk today. If you're interested in that, contact me and I can talk about that some more. The other area that we've been working on, and I think is a very important one, is time frequency. So there is a European funded project called the CLONETS design study. So it's a consortium of NRENs and industry and academics who are looking to understand the requirements and the time distribution requirements among research institutes within Europe. And they have identified that there is a requirement to be able to distribute time and frequency. And from within GEANT, we've been doing a lot of work to work out how we could support that, whether, how we could distribute time frequency within within Europe between those national measurement institutes, NMIs. One way to do it is to dedicate dark fiber, but that's quite expensive. So what we're looking at is how to carry time frequency. How to carry time frequency on the GEANT network. So research is ongoing in that area and trials. We're starting with lab testing. Interestingly, what I want to emphasize here is I've overlaid the green requirements for time frequency as identified in the CLONETS and the GEANT network, and we see an overlap there, so we see an opportunity. So we're working on how to carry time frequency mixed with data on the GEANT dark fiber infrastructure. There's been a very good work done by Renater and Refimev, who've solved this problem and are able to carry time frequency on channel 44, that's in the center of the C-band. We've done a lot of lab testing and evaluation, and if you're interested in that, I'll be talking about that at the NordUnet conference. But we've found that channel 44, for various technical reasons, isn't possible, realistically possible in the GEANT network. But we have been able to prove that the L band, channel 7 within the L band, will technically work. So the next stage is to carry out pilots to show that that will work. So just to wrap up now, GEANT is on track to complete the build of our DWDM network by early next year. We're very pleased with that, which will give fiber and spectrum connectivity to every country within Europe. And it's all built around 15-year IRUs, which gives us that certainty. And where we've got spectrum and fiber, we can grow the capacity as transponder technology improves. In 2023, we will launch a new service in GEANT on that platform called the Spectrum Service. We will provide slices of spectrum in the C-band on that dark fiber footprint. And pilots of that Spectrum Service have so far been successful and will move from pilot to production phase next year. As I mentioned, quantum is receiving very large amounts of funding within Europe, and we are active in that, and we see a lot. I expect a lot to be happening over the next few years there. And lastly, the metrology is one to really keep an eye on. A lot of work going on there to understand the requirements and find solutions for carrying time and frequency between NMIs, measurement institutes. So that's me. Thank you very much. I see my hand is raised already. David, do you want to sort of manage questions?
Thank you very much, Guy. That's a very comprehensive presentation, both about what we're actually doing today and what we're thinking about in GEANT for many years to come. I think there's enough scope there for you to be giving 6 monthly updates in probably 10 years' time, if you wish to be doing it. I would have thought there's a large program of work there, some of which will clearly be absolutely critical for the long-term future. So we come to the Q&A panel now. So hopefully we've still got all our speakers still here. Yes, I think we have. So I may go back to the chat at some point, but Buseung, as you have your hand up, please kick off the questions.
Yeah. Okay. Thanks for the presentation from the Guy. In Korea, we had the same issues to transport the frequency or timing, over the fibers.
Right.
So yeah, as you mentioned, to using the dedicated fibers is very expensive to deploy the whole thing. So we also consider the sharing the existing fiber to transport the frequency, but several issues there, like the generators or amplifiers.
Yes.
To transport the frequency, their request from our scientists is to using just one fibers, one core. So it means bi-directional the amplifier needed, but it's so not easy to deploy every amplifier in every path or that is. Is there any problem was there in Jiangning or there? So how
right. So it's this is a big technical question here, since it's a very interesting challenge. I guess that one of the best answers to that is take a look at the work that Refimev have done with Renater in France. They've managed to deploy stable time frequency. The way they did that was a combination. They went into collaboration with a company called IX Blue, who make special regenerators, and they also used special bidirectional amplifiers. So as you say, a single fiber is sufficient because you to get the very accurate time transfer, what you need ideally is to use a single fiber, so the transmission and return is on the same fiber. So when there's any variation in the fiber length vibration, you can cancel that out using sort of phase lock loops, filtering. So excellent work has been done. It's a very complex area, and we basically have got to the stage where we've identified the need. We would like to build a solution. We've demonstrated in principle working in the lab, but the next phase for us will be to do a field trial for that, and we believe we can make it work in the L band, channel 7 in the L band.
I was there with the current situation is we lease the fiber from our commercial carriers, but
yes,
it's not easy to deploy the bidirectional amplifier in their path. It means they mentioned is a national security area, so it's not easy to.
There's all sorts of problems with bidirectional amplifiers, and which are quite complex, but you can have all sorts of difficult artifacts, such as you can get reflections in the fiber, which cause the whole system to become unstable and the power level to fluctuate. And the good news is that you can fix that using these regenerators made by IXBlue. You just have to put them every 4 or 5 amplifier sites. You put in a regenerator and it will suppress any lasing instability problems.
Thank you.
Okay, thank you for that. I've just been looking through what's in the chat window. Some of the questions have been sort of answered already that we're in the chat window. Thank you to the very fast responses from people. So there's a Patch, there is an answer from Buseung about the automation the automation that they're proposing based on Network Service Orchestrator, which I think you could perhaps best follow up afterwards if you wish to. We had quite a few comments about sustainability, one source or another, one from Mohammed Tawit, and then a further reply from Lewis Choi from Tainstar TC. I mean, I certainly think that focusing on the core interests of this group, IRUs and long-term connectivity are definitely one of the things we need to focus on, not just for the biggest, most richest countries, but for some of the regional projects as well. We didn't touch on that in your talk, Jianjing, but are you also looking at IRUs or other sort of long-term capacity?